Recording in progress.
Hey there, everybody. Welcome back. We're about to dig into some more statistics. This is Math 21, Fall 2022. Math 21 is Introduction to Statistics at College of Sequoias. Today we're looking at the inference about two means for dependent samples or paired samples. So 11.2 is on the two mean test. Two mean paired test. So in 11.1 we looked at two proportion I'm going to say two mean paired samples sample test. 11.1 we did proportions with two different groups that had no relation to them other than they both did the same survey kind of thing. For the mean we break it up into two groups where the groups are related to each other. There's some connection between them, and where they're not. And so we'll be doing the unpaired group or the independent group on Thursday. Today is the paired sample test. So just to spur off the idea of why, we've got fancy hotels and unfancy hotels. Hotels like Motel 6 and the Hilton. And all over. Like San Francisco, LA. I think even Visalia region has something like the Hilton. But does it make sense to compare Motel 6 prices in San Francisco to the Hilton in Visalia? Or if not Visalia, Fresno. Fresno's a little bit bigger. I'll put Fresno. We know Motel 6 is, if I were to put it in one word, inexpensive. And the Hilton, I would definitely not classify as inexpensive. I would call it expensive. It's not the most expensive hotel, but it's much more expensive than Motel 6. Like a Motel 6 in San Francisco, at least when I took these notes, was around $115 a night. And maybe if I mean, I know we have a Hampton Inn. Let's use Hampton. Hampton in Tulare. Hampton's not as much as Hilton, but it's definitely a little more expensive than Motel 6 is usually. Hampton in Tulare was around 136. So prices close to each other. Hampton's still more expensive, but not like $200 more expensive. So these are maybe somewhat comparable in price, but But if we like factored in, do I want to stay there? Ratings, maybe, opinions, they're not close. Now, I don't have a problem with staying at a Motel 6. I like to stay cheap, but I know people that would rather sleep in their car than stay in a Motel 6. Uh, so, like, it matters a lot to some people. So, how else could we compare them? Let me pause and let you write that stuff down, and we'll continue this thought. And knowing the topic of what we're doing today might actually help steer how you would think about this. We want to pair up our samples. So how could I pair up samples where I'm now not necessarily looking at just price, but maybe other criteria? If you need this up longer, let me know. I'm about to change it out. So it might make more sense. Make more sense to compare them by the factor that does affect most people. And that would be location. What makes you want to stay in a hotel in a place? You're away from home. Generally. Generally, hotels are for when you're away from home. So it might make more sense. Let's compare them to each other. Like Motel 6 to Hilton. But we don't want to just like go, okay, let's sample 30 towns. Because the price of Motel 6, even Motel 6, changes drastically depending on which town you're in. Hilton, definitely so. Even Motel 6, you'll get like $30, $40 some places. San Francisco is $100. So let's compare them by the cities they are in. Which means I can't just like find the mean for Motel 6 and the mean for Hilton. I need to pair them up by location. Like no overall mean for each hotel because it loses the location if I do that. And so we don't want to lose the location. Let's pair them up. So we will use our sample as pairs. Based on location. To keep that element in there. Do I have that? Is that one of the examples over here? It is. But here we have Hampton and La Quinta. So, what you would ideally do is get the prices for each motel or hotel, get the price for each brand, and record it with the location. So we have two samples. We're gonna have two different hotels. We're gonna switch to Hampton Inn and La Quinta, where I have some numbers for it. So in our example, this pin is almost dead. Two, yeah. We got two hotels. Let's use Hampton Inn and La Quinta. And what page is this on in the notes? On page 128 in the lecture notes. You can see some values. Let me see if I can enlarge that table for us here. That didn't fix it. I don't know that I can make the numbers bigger. Oh, let's try this. Let's highlight the city names too. There we go. So we're going to use that data for our calculations and our tests. So for StatCrunch, to do a paired test, for a two means paired test, it's important to notice we cannot use summary data because we will lose the pairing. So we need to do we need the data. And we will do stats, t-stats, two samples, paired. I got a little more information to go over with you before we do it. But this is where we pretty much, this is, other than the criteria to use the test, this is pretty much all there is for this thing, and we're going to get out early. Definitely early. I believe probably in the next half hour we'll be done. Even doing a couple examples and get out early. Lets you work on your homework, work on your project, spend time with family during the upcoming holidays. I don't know why Black Friday events are already going on. It seems a little bit ridiculous. Black Friday used to be the day after Thanksgiving. And I got when they shifted it to like the week, the days of Thanksgiving and before. But like all of November, get out. Get out of here. It's ridiculous. All right. So we're gonna do the stats, T stats, two samples, and we're paired. What else do we need to know? Uh, some things that you can tell right away if it's a paired test. N1 has to equal N2. Otherwise, we don't have pairs. Now, N1 equaling N2, this doesn't guarantee it's a paired test. Because some people are like myself. If I'm going out sampling and getting surveys, I see something. It spaces it out for people to distribute their spendings. Oh, the Black Friday. Yeah, but only 1 or 2 weeks worth. Like usually, like people get paid. Like if you're gonna space it out for depend, so you can distribute your spendings. Maybe do like a Black Friday event every month, once every month, just 1 or 2 days every month, and that way people can spend money out of every paycheck through the year. I don't know. I'm not in charge of marketing. Uh, Back to the problems or the ideas. So it doesn't guarantee it's a paired test. If people are like me and they're doing an unpaired test where it's just they're independent samples, I still kind of want to have the same sample size. Like if I'm asking guys and girls the same questions and I'm trying to see if they respond differently, uh, they're independent groups, but I would like to have the same amount of people. So it doesn't guarantee it's a paired test because it could still be a regular independent test. But if N1 does not equal N2, I guarantee it's not a paired test. Because I have an uneven amount. This is like what happens to my socks after the sock fairy that abides in my dryer gets a hold of socks. They just start having unpaired pairs of socks. So some things we still need. We still need them to be simple random samples. Maybe in this case we randomize which cities we check. There's a lot of popular cities in America. And then once we get into, if we pick big cities, there's generally more than one of each hotel there. So randomize which hotel we pick, or at least which location in which region in each city, and pick the hotels that pair up there. This is a means test. So means test for one group, for one sample required n to be greater than or equal to 30, or we are told it's normally distributed by the people doing the sampling that have looked. Or we need to do the whole QQ plot, the critical value versus R, the correlation coefficient, and check the box plot for outliers. And to do a paired test, there must be some obvious way that they are paired. Here it's by location. But we could have heterosexual marriage couples, and broken up into guys and girls. If you're trying to do a guy versus girl, but you want them paired. So, or if you can find siblings, have every set be brother and sister, something like that. So again, we're doing stats, t-stats paired. I don't even think it says two sample. I think it just goes straight into paired. And while you finish writing that, I am going to copy this data over to StatCrunch. Hopefully Control C and paste works. Oh goody, it does. And this was Hampton and this was La Quinta. So I'm going to label them. I really need to learn how to do all this in Excel because everyone has access to Excel much more. Well, people are more likely to have access to Excel in the future. All students have access to it now, but a lot of you will have access to it in the future or something similar, either through your work or whatever. You might own the software yourself. So before I do it, what I want to point out is, remember on the 1 or 2 proportion test, we did H naught and HA had P1 minus P2 equals, and then, well, that's H naught. We're going to do something similar here. But here, for some reason, StatCrunch calls it, and I think they show it as well. StatCrunch SC uses, unless they've changed it since the last time I've used it, sometimes they make updates. They use mu D, which is mu1 minus mu2. D is for difference. So I'm going to rewrite that where I can show HA as well. H naught is mu D equals mu1 minus mu2 equals 0. And HA is mu D is not equal to 0, less than, or greater than. That's a D. I don't know if that's showing up very well. Looks kind of like an O, doesn't it? There we go. That's a little bit more D-ish. You see it over here. You'll see it. Stats, T-stats, paired. So you can see it wants to know where the two samples are. This is the D I was talking about. Mu D equals mu1 minus mu2. So they tell you. So as I go through these problems, just like we did with proportion, the two proportion tests, I am going to label which one is group 1 and which one's group 2 because it seems kind of important. If you need that up longer, let me know. And we'll bring it back. And let's just, I need to read the question first, make sure I know what test I'm doing here. So the following data represents the cost of a one-night stay in Hampton Inn Hotels and La Quinta Inn Hotels for a random sample of 10 cities. Test the claim that Hampton Inn Hotels are priced differently than La Quinta. So Hampton is different. Doesn't say greater than or less than, so not equal to La Quinta. So it doesn't really matter which order I use, but I'm going to write down what I used. I'll call that, since the first column is Hampton and the second column is La Quinta, that's how I'm going to label my groups. I should make that row bigger too. There we go. And it gives me alpha equals 0.05. So my hypothesis test, I will have H0 and HA. Mu D, which is mu1 minus mu2. Would be equal to 0. And then mu D does not equal 0. All right, let's go over and dive into that bad boy, see what we get. I said I wanted to make Hampton group 1, so I'm glad I labeled the columns. That helps. Hampton's group 1, La Quinta is group 2. Why is it not sure? There we go. It's kind of neat if you do save differences. This is kind of handy when you have this option, and you'll see why. My hypothesis test is mu D equals 0, and mu D does not equal 0. So I'm going to hit run with that and see what we get. Notice they made a column for the differences. What they've done is they've taken mu1 and subtracted mu2, just like mu D says. It says do the first group minus the second group. So 129 minus 105 is 24. 149 minus 96 is 53. And going down the list, notice that they're all positive except one, which is barely negative. This is even without looking at the p-value, that's a strong indicator to me that they are not equal. When one group, this difference thing is all one-sided. But we do have results from the test. That doesn't make the text any bigger. Okay. So let's record what we got. The t-stat is something that we care about. Is 5.27. I'll round that. And I'll put 1.16. I'll put 4 decimal places. I hate rounding when it's a 5. I'm like, that's kind of lame. Might as well do the next decimal place. But I guess that didn't help it either. And p-value. P-value is 0.0005. So I want to compare these. I want to compare p-value. Remember, p-value is always compared to alpha. Always compared to alpha. And 0.00, like if I look at the first two decimal places, 00 is less than 0.05. So p-value is less than alpha. The p-value is too low. P-value too low. We're going to reject the hoe. And we're going to support H8. HA was that there is a difference. So if I come back to the wording of the problem, I can kind of, mimic it. There is sufficient evidence to support the claim that Hampton Inn hotels are priced differently than La Quinta Inn hotels. And you'll notice I have on here, I have something where I plotted the normal probability plot differences. So when we do our QQ plot, like I didn't test the conditions to see if I could do this test. If I test the conditions, when you test the QQ plot, you kind of want to do it on the differences. So you can either subtract the differences by hand and put them in. If you set up the hypothesis test in StatCrunch or Excel, put all the data in, it's kind of easy to get the difference value. If I come back over here and look at the difference value, if I go graph, QQ plot, we're looking at differences and I add the correlation statistic. Looks like it's following a number line. The correlation value is pretty high. I could go look up the critical value, but it looks pretty linear to me. And since I'm trying to save you guys some time, I'm not going to go look it up. We could also check the box plot, make sure there's no outliers. Draw boxes horizontally. Ooh, I have an outlier. I probably shouldn't do this test the way I am. I will get back to you on how to do it if you don't meet the conditions. This reminds me I need to show you something on the proportion one. If you don't meet the conditions on the proportion one. And I'll do that after I do the next example. That's not what I wanted. Where is my... There we go. So we're going to look at another example. Let me supersize the text. And see if I can make any of this larger. So for our next problem, a quality control manager at an amusement park feels that the amount of time that people spend waiting in line for the American Eagle roller coaster is too long. To determine if a new loading unloading procedure is effective in reducing the wait time, so he wants to reduce the time. Roller coaster problem. He wants to reduce time. That seems important. He measures the amount of time in minutes people are waiting in line on 7 days. Then he implements the new procedure and he measures it again on 7 days. And to make a reasonable comparison, he chooses days when the weather conditions are similar and it looks like same days of the weeks too. So he pairs it up by day of the week, time, and presumably weather conditions. Is the loading unloading procedure effective in reducing the wait time at the alpha equals 0.05 level? Note a normal probability plot and box plot of the data indicate that the differences are approximately normally distributed with no outliers, which means I don't need to, I don't like that picture. I'm going to just change that to say 0.05. There you go. We don't need to check all that conditions. So what does it mean by wait time is reduced? So if we want to reduce the time, let's say it took 10 minutes in the first place. So the old time was 10. If I wanted to reduce it, the new time needs to be lower. Like if it's 11, the new time is not reduced. So, but if it's 9, it's reduced. So what I could do is like the old time, if I subtract this, I'm going to get a positive number if it's reduced. And if it wasn't reduced, like it's at 12, when I subtract, I get a negative number. So what I want is the old minus the new to be greater than 0. So what does that correlate to with my data? My data has before and after. So I need the before, that's the old information. Before minus new is greater than 0. That's what I want to focus on. So if I call this group 1 and this group 2, I have mu1 minus mu2, and that's mu d is greater than 0, and that's HA. That's his hypothesis. H naught has got to be the same thing, but mu d equals 0. So let's take a look at that. And he's got alpha equals 0.05. Write that down, Jones. Alpha equals 0.05. All right, let's go take a look in StatCrunch. I need the data. So rather than hopping over like I just tried to do, maybe I need to copy it. Right click, copy. I wonder if I can do transpose when I paste it. Let's go with a new column. I'm going to hit Control V. Oh, nope, I don't like that. Let's do a new data table. And I'll Control V here. All right, so it didn't work the way I wanted it to. Let me, there is a data arrange. So if the row stuff doesn't appear the way you want to when you copy and paste it, in StatCrunch you can do data arrange, and transpose will make them into columns. Transpose takes rows and switches them to columns. So that's what I'm going to do here. Transpose. I want to click them all the ones that have data. And I'll say open in a new data table. Oh, that's lame. Look at this. It put 11.6 at the top and 10.7 as the row labels. That's kind of lame. Let me bring them down here and put them down here manually. And as long as they're lined up in the row, they don't need to be the first row, but they do need to be next to each other. So I need to figure out which row was before and which one was after. I come back over and look at the table. Before started with 11.6 and after was 10.7. So I will call this before and this after. And since I did the arrange transpose, I'm going to point out you may or it may put the date, may put the top row or the first pair, first values as headers. And you want to copy them down into the table. And keep them paired in the same row. All right, so if I do my test, stats, t-stats paired. How did I say I wanted to do it? I said I wanted before to be group 1. And after, I said new for some reason. New is after. And I'll keep the differences in the table just to check it out. But I didn't want I didn't want not equal to. I wanted mu d is greater. So there's a few negative values, a lot of values close to 0. A few positive ones, few negative ones that are not close to 0. But there's a lot that are close to 0. I don't know that it's gonna be what the guy wants. And when I look at the information, I see that's correct. T-stat is 1.220 and p-value is 0.126, 1286. So if I compare my p-value with alpha, which is 0.05, looking at the first two numbers, 12 is bigger than 5, so the p-value is larger. So the p-value is not too low. Do not reject the HO, or do not reject the H0. Do not support HA. So I would have to tell this guy, sorry, dude. There is not enough evidence to support the claim that the new procedure reduced wait times. All right. We'll do a problem from the homework set. I did want to point this thing out for proportions. So if you need this up longer, let me know. But I'm going to use this problem. This was one of the problems in your homework set. And it was on worker time. And what was found, at least in the problem, so this was proportion, one proportion test. And we found that n times p times 1 minus p was less than 10. So we couldn't use the normal model. Which means no hypothesis test in StatCrunch. In the normal manner. So I'm going to come back and grab the formula that we had in the one proportion test. We saw that when we looked at one proportion tests for a 1p test, mu was equal to p, and sigma equals square root of p times 1 minus p over n. I think that's what we need. Let me go into StatCrunch and look. I'm going to write down what the information we have, though. We have p equals, in the problem I have on the screen, 11.2%, or that's 0.112 as a decimal. 65 people were selected, so n equals 65. I don't know that I need the mu in the sigma for what I want to do here. And x is that 12 of them do that. So how can I get the p-value? I'm going to come over to StatCrunch, and I'm going to go Stats, Calculators, Binomial. So the proportions from the 1p test, proportions, the answer to these questions follow a binomial distribution. all the time. They will always follow a binomial distribution. If we're lucky, they will meet the criteria for the normal model as well, and we can use the normal distribution. But in this case, they don't. So we got to do the binomial distribution, stats, calculators, binomial. So what the stats, oh good, I don't need it. What the binomial calculator wants is the sample size, which was 65. They want our target percentage, which was 112. And this had 12 people. I'm going to put 12 here. And the way it worded it was, if I click back on the ask my instructor thing, they wanted P to be greater than 0.112. So I'm going to make that say greater than. And so what I'm getting there is 0.026659993 from this box right here. If I come over here to that question, why did they want 0.056? Did I enter something wrong? Let me come back and look. Maybe make it greater than or equal to. There we go. My bad. It was P was greater, HA was P was greater than 0.112. So over here in StatCrunch, I'm doing X is greater than 12. N equals 65. P equals 0.112. This greater than equal to matches up with that one. And you get the probability that X is greater than or equal to 12. That thing right there, it's spitting out 0.0556. This is our p-value. Okay? So, that's... Oh, chat. Oh, Natalie was trying to tell me all along. Thanks, Natalie. She's like, quit wasting my time, Jones. You're doing it wrong. And so if we did the greater than or equal to, we'd get the 0.0 to 3 decimal places. This is 0.056. So that would match up. So that's how you do that problem. I kept that loaded as a tab on my browser so that I would remember to do it. Let's take a look at one of the questions in your guys' section. I had one written down that I want to do. Looks like number 11. Chapter 11 and number 11. How about that? To test the belief that sons are taller than their father. Let me get another whiteboard. This is my last clean whiteboard, so I'll have to clean them if I need more room. This is the last one we're doing now. To test the beliefs that sons are taller than their fathers, a student randomly selects 13 fathers who have adult male children. She records the height of both father and son in inches and obtains the following data. So there's a data set. The question is, it says, Are sons taller than their fathers? And there's a data set, and they gave me alpha equals 0.10. They do tell me a normal probability plot and box plot indicate that it's approximately normally distributed with no outliers. That's good. What we need for this condition to be met is the differences are normally distributed or the sample size is large. And we have been told that the differences are normally distributed. Right there. What am I missing? Oh, I need dependent stuff too for the paired test. What? What are they going for here? Those are the conditions.
Would it be A as well?
We can check it. That's for proportions. But maybe that's what they're going for. Really? Okay. So let D1 equal X1 minus Y1. I don't know which one's X1 and Y1, so let's look at the data set. So fathers are X, sons are Y, and I want sons taller than fathers. So if I did sons minus fathers, that would be greater than 0 if the sons are taller. But they don't want me to put it in that order. They want this would be Y minus X. So we don't want it that order. We want to switch this around. If we switch this around, we need to switch this around. So changing the order changes this sign to less than. So that's pretty important. And I'll bring that up and load it back into the thing for in a second. But I got mu d equals 0 for h naught, and mu d is less than 0 for the order they put it in. X1 minus Y1. This is such a weird way of putting it. Fathers minus sons. When you want son, I don't know. Maybe I just like positive numbers. And that's where the hard part was. People got confused on that, which order to put these in, and apparently even the top part's a little in question. If I load this into StatCrunch, I can do our paired test. And I need son. Oh, they have fathers minus sons. They put it in the wrong order. Fathers minus sons, and that's got to be less than 0 to do that. At least in my head, that's the wrong order. Maybe I'm just neurotic. So this was H naught. Mu D is greater than 0, and mu D is, I'm sorry, that's HA. H naught is mu D equals 0. We had alpha up there, alpha equals 0.10. What I got from my computer work, tstat, is negative 0.029. And the p-value is 0.4886. So the p-value is definitely larger than alpha. And notice they didn't give us use 0.05. They used a different value, and we're still higher than it. So the p-value is not too low. We do not reject the HO. And we do not support HA. So the claim that sons are taller than fathers, there is not enough evidence to support the claim. That sons are taller than fathers. I have the information I need for the stuff though. I'll come back over here, enter it in. T naught was negative 0.03 to 2 decimal places. And the p-value to 3 decimal places was 0.489. Should the null hypothesis be rejected? No, we said do not reject. We do not reject the H naught because the p-value is greater than the level of significance. That means there is not enough evidence to conclude that sons are taller than, which is what they had in their question, that sons are taller than their fathers at the 0.10 level of significance. So that's working through that one. Make sure you pay attention to the order they demand. For me, I would have done sons minus fathers in the get-go, but my ordering y minus x, it would have given me the wrong information. Like if I go look at it, if I had done y minus x, so if I did sons were taller than fathers, and I did it the way I wanted to do it, notice the t-stat, it's the same number, but the sign is different. So on the other version, it was negative. This one is positive. So they would have told me I'm wrong. P-value is still the same, because I still tested son compared to father correctly. I just didn't do it the way they wanted. They would have marked me wrong, and that would have been that. And that's it for today's lesson. It wasn't exactly 7:30, but we're almost done at 7:30. If I didn't do that extra proportion problem, we would have been done earlier. Other than that, I am done. Have a good evening, and I will see you guys on Thursday. I got 6 people in here. Who else is in here? Oh, people are already dropping. Okay.